Hello again and welcome back to the ADEPT tutorials. In this tutorial we'll be going over custom variables and variable lists. So I'll go ahead and list out again the files that we'll be using. We have the adept.jar that we've been using all along, the same 10 input files. There's the test that we created with the basic tutorial. And now I've got this other file here that will also be included in the package, which is the variable list.xml. We're not going to use it in this first execution of adept, but we will be using it in the second one, so just make sure that you have that file ready to go. Okay, so our first execution, we're going to be doing two, like I said, is going to be like we did in the previous two tutorials for the filters and advanced. We're going to do java-jar and then the adept.jar and the star.txt or whatever you have the extension for your input files. Okay, and that'll open up, and here's the main window with all the files in there. Okay, so the first thing we're going to go over are these custom variables. So go ahead and go to custom and new, and for each custom variable you have to create a unique name. We'll start with temperature, say. And as we know, beta is the inverse of temperature, so temperature would be the inverse of beta. So we'll go ahead and write in 1 over beta. And you can see here I just typed in BE, and there's a autocorrect implemented, so that after you write the first two letters of a variable that's already defined, it'll try and finish the variable for you. That helps in cases where either you have a really long name, such as some of the correlation names, and also some of these variables require the upper and lower case to be correct. The string actually has to be 100% correct in terms of upper and lower case, because there are some names that definitely depend, like lowercase t and uppercase t depend on the case as for what you're trying to actually extract. So this will help you figure out if you've got the right variable. If you were to type in, say, lowercase be, it's not going to autocomplete it because that's not currently in the list of variables. If you do a capital BE, it'll finish it to beta. So then after that's done, you just hit enter. And there's all the temperatures for those 10 files, and we'll go ahead and just bring out beta just to show you that it is in fact 1 over that value. Okay, and then the next thing that I want to show is how to index the correlation points if you want to examine a particular correlation point, maybe with an equation added to it, just in case you need to access one particular point. We'll go ahead and just call this test. And we'll just use the ZZ spin correlation for this example. So as you can see, you have the name of the correlation, and then you have the square brackets surrounding the coordinates with a comma separating them. And the values themselves, here we have 0 with 4 decimal places and then another 0 with 4 decimal places. And the reason for those decimal places is that those are the same, that is the same string that is found in the input file. You need to have that exact same string because that is what's being compared. Those numbers are not actually being parsed into doubles. So the number that you put here has to be the same as the number in the input files. Luckily, the autocorrect helps you there. The autocorrect gave me these 4 decimal places because that's what's already been input into the system. But just something to keep in mind, that if we were to just put in 0, 0, it would tell us that that variable was not found. So we'll go ahead and do that. And I'll just pull up that point as well, just again to illustrate that that is in fact what we're looking for. Yep, all the values are the same. Okay, and then the last thing I wanted to show with the, or actually 2 things left I wanted to show with the custom variables. The first one, we'll just call it test 2, it's just a little illustration of the basic math that the equation editor can do. Let's say we have 1 plus 2 times 3 divided by 4 minus 2, let's say. And we can even put parentheses around these as well. So all of these operations are acceptable, and I believe this will be 2 times 3 divided by 2, so this will be 1 plus 3, which is 4. Okay, we'll go ahead and hit enter, and sure enough, all those values are 4, and of course they're all the same because the equation doesn't actually extract any file-specific data, so it's the same for each file. Okay, and then the last part I wanted to show is that ADEPT is capable in its equation editor. It is able to use functions. So we'll go ahead and just do test 3. And there are a few functions that are currently built in. There is absolute value, which is denoted by ABS. And the functions are used with in the normal fashion of function name and then parentheses and the parameters inside separated by commas. So if we did ABS of -3, that would give us 3, positive 3 for the results. There's also square root, SQRT, of the value. Say if we had 4, then the results would all be 2. The other one is power, or denoted by pow, and that is the base, and then the second parameter is the exponent. So this would result in 2 cubed, or 2 to the third exponent, and that would result in 8. And then the last function that is implemented right now is actually somewhat similar to the special outputs, but it is applicable to every file, which is why we have it as a function instead of a special output, and that is the average correlation. Now, the average correlation takes in a correlation name, so we'll say ZZ spin correlation function, and we'll go ahead and just get rid of the indexing there because we don't want that, and then end parenthesis. And what this is going to do is it's going to take all the points within that correlation, and it's going to average them. And the average does take into mind multiplicities. So the origin point will only be counted once, and points along the diagonals and along the x-axis when y equals 0 are counted 4 times. All others are counted 8 times. That's due to the reflection that's done as if you were to average the all the points of the whole or the reflected correlation set from the special output. This average would be the bottom value there. So we'll go ahead and hit that. And there's are the averages for each of those files. And the reason, like I said, that we have that is because this can actually be done for each file. If we go and include file names, you can see that these are the average ZZ spin correlation, just named test3, for each of these files. Okay, so now that you have an idea of how to create an equation in ADEPT, we'll go ahead and exit out of ADEPT. And now we're going to take a look inside this variable list.xml. And I'm going to go ahead and pull it up here. And I'm going to open it up in just a notepad so we can really take a look at the formatting here with enough room. Okay, so if you're not familiar with XML, this is a really simple example of it. So XML is based off this nesting of elements. An element is something surrounded by these brackets, these left and right brackets. And each element must be ended with this, this / here. And each XML file also must start with this, this XML encoding line. So if you end up making your own variable lists file, this is going to be needed. Okay, so the variable lists, actually let me pull up the ADEPT again just one more time so I can just illustrate graphically what I'm trying to convey. So right now we have the extended and custom menus here. Extended contains all of the data elements in the input files, like I've said before. But if we want, say, maybe a smaller list, like maybe if we only want the, maybe the physical parameters or maybe just the energies, we could create a menu. So say above extended, it would have energies, and inside that menu, we would have kinetic energy, total energy, etc. So that's what we're trying to get at here. That's what a variable list is. So this list here, in this main section, so each XML file is going to have this main root element. In the variable lists file, the main root is this variable lists element. And then below that, we have this list named basic. This is just a name that I came up with of just some basic data types that we can play with to illustrate the variable lists. So, this list, there are three things that you have to define for it. You have the name that's going to be displayed. Again, we can look at extended would be the name of this menu. And then settable is talking about its visibility. Here we can go to options and we can decide to not show extended variables. And now it doesn't show up in the menus anymore. That's what settable is. If you were to set settable to no, it can be either yes or no. If you set it to no, then it would not appear in this options menu. It would either be on all the time or off all the time. And the decision at that point on whether it's going to be on or off is decided by this one, default on. That's what it's set to when ADEPT first launches. So in this case, basic is both settable and on by default. So when we start ADEPT, basic will be visible, and we will be able to toggle whether it is visible or not. Okay, and then moving on. So this settable and default are actually only necessary for the top level lists. For any sublists, which basic has here, it has one sublist called basic parameters. You cannot tell whether that's going to be visible or not. That's only for the highest level menus. And that's to avoid too much clutter. In the case that you have a lot of these such menus, it's to avoid clutter in this options menu. So, so these sublists will only have name. Pretty simple. And as you can see, the lists can be nested as far down as you want for your own convenience. And then we'll move on to the variables. So a list can contain two kinds of elements. It can contain either another list, which will create a submenu, or it can contain a variable. So I can show you, let me enable extended again here. So in this case, parameters is a sublist of extended. And all of these, U, beta, etc., these would all be considered variables. So here we have a variable, and you give it a name, in this case lowercase t, and then you can give it a description. It's best to give it a description. I believe it is mandatory to put one in. You can make it empty if you want, but the description attribute has to be there. And the description is what will be shown if you were to mouse over that variable. That's not available for the extended variables because that has to come directly from the Quest output file. But for these special ones, you can define an actual description. So when you're hovering over it, you can say, okay, this is the hopping amplitude, etc. And then the variable. So this third section here, so the first two are necessary. Name and description are necessary. However, this third one can be one of two. You can either have it be variable, which is the name of a variable which has already been described. In this case, tup is described in the direct input files. And then you could call it, instead of variable, you could use equation, which now throws back to the custom equations where we had these strings, these inputs of an equation. And the reason why I did the custom variables before is because you are allowed to put in anything here that you could put into a custom variable. This basically is a custom variable. So yeah, that is those. And then after you define something here, you could lower, say, variable t. In fact, let's go ahead and do that. Let's just call this one t. Actually, we'll call it t2 since we already have a t. And we will define it as t. So this is going to refer to this t here. But the point that I'm trying to get across here is that the variable that is described here can even be a predefined equation. An equation basically is a new variable, whereas the variable attribute is something that has already been defined. So we'll go ahead and now exit this and save it. And we'll close ADEPT. And we're going to rerun it. So now we're going to run java-jar adept.jar. And this time the first command line argument is going to be the variable lists.xml. And then you're going to continue on with whatever input files you want to give it. Okay, now we have, again, our main window, all our files are up, and now we're going to have this basic menu with all the things that we had before. Let me go ahead and open up that XML file actually, again, just so we can really see how the two work together here. Okay, there we go. So as you can see, there's a basic parameters list that has the T, U, muta, and uppercase T. And then below that sublist, we have T2, total energy, and density. Oh, and I didn't note earlier that the descriptions for total energy, and then I believe it was kinetic energy up here before, and now density, the descriptions are not correct, and even these variables are actually not correct. I think that was just a copy-paste error on my part. But we'll go ahead and just take a look here. So then you just go ahead and pull up whatever you're looking for. And it should be noted that by default, the extended variables are actually turned invisible when you input a variable list file. It's assumed that if you input a variable list file, you know what you're looking for, and you don't need you basically don't need the clutter of this all-inclusive menu. Whereas if you don't have a variable list file, then you have nothing else to grab your data from. So we go ahead and make it visible. So yeah, I believe that is it for the variable lists and custom variables. And with that, that should be about it for ADEPT. If any future features are added, more tutorials will be added to the channel. That's youtube.com/user/questadept, one word, all lowercase. And if you need to reach me, you can reach me at questadept@gmail.com. I'll go ahead and type that out here just so it's clear. That is questadept@gmail.com. And you can reach me there for any support questions you have. Thank you for tuning into these tutorials, and good luck!